minus the top, or 10,000, times the derivative of the bottom. Okay. Well, the derivative of 1 is 0, right? The derivative of 19e to the negative t over 5, well, the 19 would stay, constant multiple rule. E to the negative t over 5 would stay, derivative of power of e. But we would have to multiply by the derivative of this exponent. Okay. Now, that can look confusing if you think of it as negative t over 5, but how about you think of it as negative 1/5 t? Okay. I think that's a lot easier way to think of that exponent. And then isn't the derivative just negative 1/5? All over the denominator squared. Okay. Now, we're not after a beautiful derivative answer, but I'll tell you what, I wouldn't want to even type this into my calculator, so I'm going to clean up that top a little bit and then go ahead and leave the bottom and then just plug in the numbers that I need. Help me simplify the top. Decide what, because we got a negative 10,000, a 19, and a negative 1/5. We can multiply those all together and make this something e to the negative t over 5. Okay. Decide what that something would be on the top. Did you get 38,000? Okay. All right. So again, it's not about a pretty derivative here. We don't need a pretty derivative, but it's about one we can at least use in our calculator easy. Okay. So now we're going to plug 1 in there, both places, t on top, t on bottom. Okay, get an answer. And then 10 in there on top and bottom and get an answer. Okay. Make sure you're typing this in with us. Again, it's not an easy thing to type in. And if you don't do parentheses right, you'll get a wrong answer. So let's plug in 1 and 10. So I ended up with 113.5 and 403.2. Okay. The units on that would be, well, the P stands for population of fish, and T is time in months, so that would be fish per month. In our assignment, we've been working on those derivative or those applications of natural log functions with derivatives and things. That's where that question comes from. 21, the same thing. Okay. The annual rate of inflation averages 5% over the next 10 years. The approximate cost of goods and services during that year is this equation, okay, where T is the time in years and P is the present cost. All right. The price of an oil change for your car is presently $24.95. Estimate the price 10 years from now. Okay. So what that means is we want to put $24.95 in for P. Multiply by the inflation, 1.05, to the 10th power. All right. So we're just going to go ahead and calculate that. And in dollars and cents, then, that would be $40.64. Okay. All right. Again, kind of like this A, just kind of straight calculation sort of business. B, though, there we see that word again, rate or rate of change. Find the rates of change of C with respect to T when T equals 1 and T equals 8. All right. Now, this is an interesting thing to differentiate for two reasons. One is that it's got a P there. But because of the constant multiple rule, that would just stay p. So p times. Okay, we don't want to use the specific number from part A. We want to go back to this equation for b. Okay. Now, we talked about one like this the other day where you have, it's not e to a power, but it's a different base to a exponent that's a variable. Okay, and I think on our yellow sheet, we picked out what rule we would use in this situation. If you haven't found your yellow sheet yet today, please do that. And it's not the same as back in the day when we used to differentiate x to the fifth, right? Because here your base, the base was the variable, and the exponent is the constant. Okay. Do you see that we have exactly the opposite situation here? Okay, so it's not like this. It's a little more like this. E to the, I guess you could do e to the x, all right, or e to the x squared. It's a little bit like that, okay? If we differentiate this, we know that the power of e stays the same, but we have to multiply by the derivative of the power, and technically we multiply by the natural log of e also, but what is the natural log of e? 1, okay, so we don't even write that. This is what I wrote on my rule number 10, okay? E to the u times u prime, and again, really there's a natural log of e there, but we'd never multiply by it. I only say that because it's comparable to 12, okay? 12 is the rule we're going to use, but instead of a base of e, we have a base of a. But remember from our little notes up here, a is a constant, okay? So our derivative is going to look like this. P for the constant multiple rule times 1.05 to the t. It still stays the same base to the same power like it does here, okay? We multiply by the derivative of the exponent, which is 1. And then here's the new part. When we don't have a base of e, we do have to multiply by the natural log of 1.05. Okay. So again, that's this rule. The derivative of a to the u